So what's up guys, it's Simon Firaz and today's video is on AQA A Level Chemistry 2017 paper 1 walkthrough, but it's a bit different this time. Instead of me going through, all I'm going to be going through is basically none of the calculation kind of questions, just the non-calculation questions. Calculation questions they're not that difficult, and the difficult ones I might go through day before the exam. So as we change 1 mole of a solid ionic compound is formed from its gaseous ions. This one I'm going to go through, but I mean like the big, you know what I mean, the calculation questions. You guys know exactly what I mean. So this one, I'm going to have the aqueous ions at the bottom. Actually no, I'm going to have this at the top. I'm going to have the gaseous ions at the bottom. And now I'm going to find the enthalpy of lattice formation of silver iodide. Actually, lattice formation. Quick look on my textbook. So the enthalpy between 1 mole of solid ionic compound is formed from its gaseous ion. Okay, now I want to find the lattice enthalpy of formation of silver iodide. Okay, let's have a quick look again at this question. So I want to find the enthalpy of lattice formation of silver iodide. Okay, I overcomplicated it too much. Okay, that's how your normal cycle would look, Born-Haber cycle. I want to find, this is the enthalpy of lattice dissociation because I'm dissociating the solid into its aqueous ions. So if I want to find the enthalpy of lattice formation, it's this arrow forming from my aqueous ions. Enthalpy between 1 mole of solid ionic compound formed from its gaseous ions. Sorry, yeah, not the aqueous ions, gaseous ions. So you can see how you're using the definition to kind of help you. So if I want to go from here to here, well, I know to go from here to here is 112. Then I know to go from Ag plus gaseous to Ag plus aqueous is minus 464. So I'm trying to go the opposite way around. So I'm going to do plus 464 plus 293. Because think about it, if I want to go from gaseous to aqueous, I want to go that way, but I want to go aqueous to gaseous. So it's going to be 112 plus 464 plus 293. And that would give you but that would give me up to here, right? And I know to go from, okay, yeah. So that whole process, so from here to here, is the same as going from here to here. So that equals x. But I don't want to go from here to here. I want to go from here to here. So I'm doing the opposite around, so that's minus x. Yes, so therefore x is minus 869 kilojoules multiplied by minus 1. It can be sometimes quite tricky. I don't know why they put it as the first question. It is kind of annoying. So then it says, gives a smaller numerical value. That's because Ag contains covalent character, hence forces holding the lattice together are stronger. Identify region, use to indicate the presence of iodide ions, silver nitrate, and the observation would be a yellow precipitate. Again, we're going to skip these kind of big, this is not even a hard question, but we're going to skip these buffer kind of questions. They're all the same, like the method you use for these big buffer pH buffers, just learn the methods. Again, okay, suggest whether it's pH in an alkaline because the concentration H plus equals the concentration of H minus. Always write that down. Okay, this one is very difficult. I think it's the most difficult question of question 3 because it really requires you to use multiple topics. It says predict whether the pH of magnesium hydroxide is larger or smaller than or the same as pH of calcium hydroxide. What do I know about magnesium hydroxide from group 2 alkaline metals is that it's sparingly soluble. You have to know that key term is in the specification. Sparingly soluble, right? So if it's sparingly soluble, that means it's very it means it's low in solubility, right? So how can I apply that to the question? Well, then I'm going to have a lower pH because what it says is that I'm adding magnesium hydroxide to 1 centimeter cube water. I'm going to have a lower pH because magnesium hydroxide is sparingly soluble. And how would that affect the pH? Because therefore I'm not going to absorb as much the water, so the pH is going to be lower. Very difficult one, honestly. Okay, skipping 4.1, 4.2. Write an equation including state symbols showing atom titanium was anode by electron impact. Okay, electron impact is when the sample is vaporized and electron going to use fire high energy electrons, knocking one electron becomes positive ion. So it's going to be like Ti gaseous, Ti plus gaseous plus E minus. Perfect. And the one with the that would reach detector first is going to be the one with the lowest MZ value. So this one, which is 46. Skip 4.3, skip 4.4, skipping 5.1. Okay, question 6. Write an equation for the reaction of phosphorus with excess oxygen. P4 plus 5O2 form P4O10. Got a test to distinguish between sodium oxide and phosphorus oxide. So sodium oxide and phosphorus oxide. Well, we can add water. Or we could use the idea of pHs. I don't know. There's a lot of options we could choose. We could even use sodium carbonate. Um, let's just use add water, add litmus paper, add litmus paper, litmus paper, and then litmus paper is blue with sodium oxide. And red with phosphorus oxide. This is the kind of question I would put on a flashcard. Say to have a crystal structure on silicon dioxide, sulfur trioxide. Silicon dioxide, you have to know this. It's giant covalent. Sulfur trioxide, I think that would be more difficult. You're not used to this. Sulfur trioxide is just SO3, right? It's just a simple molecule. So molecular. Beautiful question now, question 6.4. Beautiful because it is a beautiful question, easy 4 marks. So covalent bonds between atoms, covalent bonds in silicon dioxide, van der Waals between molecules and sulfur trioxide. Covalent bonds are stronger than van der Waals. Covalent bonds take more energy to be overcome. Beautiful. Question 6.5. Okay, now you've got these questions a lot of students hate. And it is these 1 markers. So write an equation for the reaction of sulfur dioxide plus hydroxide solution. So my advice is just do what the question tells you. So sulfur trioxide with potassium hydroxide, SO3 plus KOH. Potassium hydroxide is base. Sulfur trioxide is an acid. Acid plus base, we form salt plus water. Obviously, you know this from GCSE. So I know I'm going to form H2O. So what's my salt going to be? Well, it's going to be K something. So it's going to be, well, now you have to think logically. I've already got a water molecule here. So I need 2 hydrogens. So I need a 2 here. I have to have a 2 here. And because I have to have a 2 here, then it's got to be K2. And then I've got how many oxygens on the left hand side? 5. So I'm going to say K2 SO4. Perfect. That's how you would attack that kind of question. Really, these are the ones where you have a look. But I don't think you are meant to memorize these ones. I'm just having a look. Are these things you need to memorize or not? I think they are. I think there is a format you need to memorize. It says in the booklet SO3 plus 2OH minus 1, SO4 2 minus plus H12. So even more equations for us to memorize. Okay, perfect. Find equation for action. X is magnesium oxide, phosphoric acid. So magnesium oxide, MgO, phosphoric acid, H2PO4. So I'm just going to form Mg3PO4 2. Now this is the hard part students struggle with. How many water molecules I'm adding? Well, let's just think about it. I've got 9 oxygens on the right hand side, and I've only got 5 on the right hand side. So if I do I need to add a 3 here, and then now I've got 7 oxygens, and on the left hand side I've got 9 oxygens on the right side, 3 MgO plus H2PO4. So Mg3PO42 plus H2O. Now you need to really think what my balanced thing's going to be. Well, I need a okay, it's going to be 3 and 2 then. 3 and 2. No, sorry, it's going to be a 3 here and a 2 here. 2 H3PO4 there plus 3 H2O. Spade formula sulfur dioxide reacts with water. Again, something you need to memorize, and it just looks like this. And you've got your lone pair of electrons here in brackets. Perfect. Same type of bonding between oxygen and hydrogen compounds. So just break it down, right? Don't just guess. Oh, it's got to be hydrogen bonding, or it's got to be something. No. Oxygen, hydrogen. Well, they're both non-metals, right? And because they're both non-metals, it's going to be covalent bonding. So yeah, that's how you attack that question. 7.2 stay with the chlorides are not considered to be ligands. Because in order for something to be a ligand, it's got to be able to donate a lone pair. Well, the Cl, in this case, you obviously have to apply it to a question. So Cl minus does not donate a lone pair to Cu2 plus. An excess ammonia is added to sample solution A to form solution B, where solution A is this. And it said excess of ammonia. Okay, so with a copper, it's going to be 2 plus, Cu2 plus. And you do need to know this one off by heart. Let me get my sheet. It is there's actually 2. What does it say in the question? To form solution B. Okay, because it's a solution. Okay, that's a bit tricky. I'll give them that. That's a bit tricky. Yeah, a bit tricky. Yeah, that is a bit annoying. So you know these transition metal questions, a lot of them they're just AO1, right? But they did try to trick you out. Excess ammonia solution to a solution, so it's got to be with the reaction of metal aqua ions with excess NH3, and it's the only one that actually happens, ligand substitution. So basically what happens is you've got your COH2O 6Cl2, gives you the question. No, sorry, CuH2O6 2 plus, and then you're adding 4 NH3s, and then you're forming CuH2O4 OH2 plus 4H2O. It's the opposite way. CuH2O2 OH4. CuH2O2 OH. NH. Why do I write that? NH3, obviously. You get the point. And the color is blue, deep blue. Very important you say that. Deep blue. Aqueous sodium carbonate. Let's see how many more questions are left. Alright, not too many. Obviously, I'm going to skip all the big ones, the big calculation ones and all that. Okay. Aqueous sodium carbonate. Add to another sample solution A to form blue-green solid C. Identify the blue-green solid. What I would do is just go with what it tells you. Just literally follow the question. This is not too difficult. So it tells me solution A is this, and I know that's 2 plus, and that's added carbonate ion, CO3 2 minus. So I'm going to form CuCl3 plus H2O, and it's going to be 6H2O. Perfect. And that's the solid. That's the blue dash green solid, because blue precipitate the blue dash green solid. So it's CuCl3. Perfect. Reagent D was added to another sample solution A to form a yellow-green solution. Identify reagent D of an ionic equation for reaction occurs when the yellow-green solution is formed from solution. Okay, now it's getting really complicated. Okay, reagent D was added to another sample solution A, but solution A is CuH2O6 2 plus. Reagent D was added to form a yellow-green solution. Yellow-green. I've added carbonate ions. I've added excess ammonia. What else can I add? Reagent D. So it's either hydroxide ions or chloride ions. And because it says reagent D was added, therefore it's going to be hydrochloric acid. And therefore, if I add Cl minus ions to this, I'm going to form CuCl4 plus 6H2O. That should be 4 there. 4. Obviously, it's 2 minus, silly me. Yeah. Perfect. That is the equation. Okay, now normal equation. Create a color image. You can use term concentration in this. I'll just memorize this question again. Just full 3D subshell, and it's colorless as cannot absorb frequencies of visible light. Describe the students distinguish between potassium nitrate, potassium sulfate, so barium chloride. No visible change. No visible change. And this one, it goes from no visible change to white precipitate. Yes, white precipitate. Distinguish between magnesium chloride, aluminium chloride. So we've got the Mg2 plus ions and the Al3 plus ions. So you need to add sodium hydroxide. And this one is white precipitate. So white precipitate. But with the aluminium one, it's also white precipitate. But it dissolves in excess. This is just year one knowledge. And that's 6 marks just for year one. The full question 8 just to test your knowledge on that. Question 9 is skipping, obviously. Yeah, big calculation. It's not a calculation question, but it's just a big question. Let's skip it anyway. Question 10. Reduce the oxidation state of nitrogen NO3 minus NO. NO3 minus an NO. Okay, oh sorry. So that's going to be +5 +2. Because oxygen has an oxidation state of -2, so we've got 3 oxygens -6. Overall charge is -1, so you need a +5 to get an overall charge of -1. And this one, oxygen, is -2, therefore nitrogen has to be +2. Say the weakest reducing agent. The thing about reducing agents is always on the right hand side. And the more positive, the weaker. So I'm just going to look for the positive one, this one, and therefore that is the weakest reducing agent, Cr-. So again, something you would just memorize in order to save time. Just memorize, okay, reducing agents on the right hand side, more positive, weaker. Right, conventional representation of the cell as an EMF of plus 0.3 volts. Of the cell as 0.343 volts. So what we need to do is, we know EMF is E reduced minus E oxidized. I need to find 2 possible pairs of combinations that would give me 0.43. So which one would give me 0.43? Actually, this is not even on the mark scheme. I'm skipping this one. I think they got rid of this. In the mark scheme, it does not appear. Question 10.4. Use data to identify an acid that was oxidized copper. Oxidized copper. Where's copper? Copper's here. So in order to oxidize it, it's got to have oxidize it. In the meantime, let me finish off the rest of the questions. I'll find out what to do for that one. Okay. So this one. Just one reason why people eat these foods, not suffer from food poisoning. No, let's start from here. Ethanol ions, okay, react with aqueous 3 plus ions. So ethanol Fa3 plus ligand substitution reaction. Okay. Round equation for this reaction. So I've got ethane dioate. What is ethane dioate? C2O42 minus. So I've got iron 3 plus plus C2O42 minus to form what? Fe C2, I need a 3 here, C2O43 3 minus plus 6 H12. And then it's just about enthalpy equals 0 because you can clearly see 6 FeO bonds broken and 6 FeO bonds made. So same number of bonds and same type of bonds made, and that. Draw a displayed form of the iron complex reaction question 11.2. So once we draw a displayed form of this, okay, that's a bit difficult, isn't it? So what you have to do is you have to know what to do, right? This, so we've got Fe, and I've got my oxygen here, this is how I would do it. Let me get ethane. It's got the dioate. Again, this is something you literally need to know how to memorize, and you get the point. It's something you need to memorize. Bond angle though, 90 degrees, and type of isomerism. It's not cis trans. Got to be optical then. Low concentration. And that's it.